Welcome to the live stream. This is about the fourth time we've had to set up a stream because, funnily enough, the YouTube mobile app is not very good at allowing you to do landscape video. I'm just gonna share the stream. I think I've lost all my audience now in terms of trying to get the stream working, but hopefully people will join during the video. And sorry for any background noise. I have my windows open because obviously I don't want the whole room to fill with, solder smoke. I can see all your live chat messages through my laptop, so I should be able to answer any questions or just have a general chat with you. Let's begin by setting this up. It's very useful to have one of these to magnify what we're going to be looking at. It's not in the best position right now. Maybe I'll put it like that. I will give that some power. Oh, right, okay, look at that. Alright, and as well as that, I will get some props out. Okay, so let's talk about what we're going to be doing in this stream. So, to give you a bit of a background, I recently fell in love with this lovely 80s computer called the Psion Organiser II. It's made right here in the UK and launched in 1986. And it's a beautiful little device. It's very basic, but I already use it for my shopping list, so I can add my green pesto and my, toilet roll. So I already have a useful purpose for it, but what I thought would be cool was to somehow modernise the device and connect it to the internet. So fast forward about probably a month, I bought another one. They're only about 20 quid on eBay. They're quite inexpensive nowadays, given how high tech they were back in the day. This one I've kind of wired up. You'll notice that on the back of the Organiser 2 there are these little slots where you can put in data packs, and I've already got a data pack there. And these are normally used to increase the amount of storage you have on your Psion, or to run third-party programs that you can buy from a shop. It looks like we've got 4 people watching. That's nice. I've got an audience now. I wasn't talking to myself. Feel free to say hi in the chat, by the way. I can read your messages on my laptop. So, right here is my prototype on this breadboard for what we're going to actually build today, which here I've connected to a lovely little Raspberry Pi Pico 2W, which I had a lot of fun with trying to get it to talk to the Psion and to pretend to be one of the data packs which fits in the back slot. But today we're going to actually solder the actual module that I want to make. This is the PCB, which is currently unpopulated, but I had this made a few weeks ago by a German PCB manufacturer, Eisler. I'm not sponsored, but they seem to be quite high quality, so I went for them. And I have no idea if this will work today or not, but we will find out. So yeah, it's called OrgNet, which is the thing I'm going to be making, and this will hopefully have a Wi-Fi module on it and also Bluetooth as well, so that you can get this thing to talk over the net and potentially visit websites, send messages on chat rooms. I mean, the possibilities are endless when you connect such an old device to the internet. I think there's been quite a real interest in connecting retro devices to the internet recently. I think there are quite a few other retro computers, slightly bigger than the Psion Organiser, that already have Wi-Fi modules available for them now, so that's quite cool. But yeah, we are going to solder this thing, and right here I've got this lovely bit of metal, this stencil from Isla, which we'll use to apply the solder paste. So standard practice when it comes to PCB manufacturing, you can get them quite cheap, these PCBs. They're probably about 20 quid for 3 of them, which is pretty good going, and then a tiny bit more for the stencil. Yeah, not bad. Anyway, it's time to get out the star of the show, which is oh, I love this sort of thing. This is my SMD reflow hotbed, which essentially put the PCB on there, and all the components kind of melt into place once you put solder paste on top. It's a bit dirty, but I'm sure it'll be fine. And then, of course, what are we actually going to put onto the board? Well, we've got a whole box of components from Mouser here, and hopefully it doesn't contain any personal information. I don't want you to know where I live. I will just remove this invoice from the box. These are some lovely components. There's quite a lot of them here because I also bought some components for another project, so I will just quickly filter them out so that we're not accidentally putting on the wrong components. That's the trouble with, so we need that. A bunch of little resistors. Yeah, small resistors for the other project. A lot of different components. I've got a few projects on the go, so that's why I kind of got them in bulk. Just so I got multiple things on the go, and hopefully for cheaper as well. So I'm just currently reading the information on each pack to tell me. I'm looking at the component number to see if this applies to this project or my other project. And where I did that, it just have a different numbering format for each component ID. So I can get through these relatively quickly before we actually do something. So I've got about 40 bags in total of things, so not great for the planet, unfortunately. Kind of wish that, you know, I want so many plastic bags, but that is electronic component development for you. That one's for this, that's for this. There we go. I think at the bottom of the box are all the different things which I'll be using for this project. Yep. I already have a bit of practice with my other projects in terms of what we'd be doing in terms of SMD soldering. If you don't know what SMD soldering means, it's essentially rather than soldering through the holes, which if I had a PCB, if we look at the PCB, we've got holes and components slot through them. They're kind of their feet, which are metal contacts. They slot through the holes. That's through hole soldering, but we're doing SMD soldering where we put each component on the board on top, and essentially each component has to make contact with the board. It basically lays on top rather than going through the PCB. So probably not the best description there, but I'm sure you can probably figure out what I mean. Google it. So these are the components that I'm going to be using. I'm going to move my laptop out of the way. It's time to... Won't heat that up just yet. And I also have, if I can get it, I've got boxes and boxes of different things. I have these, here we go. I've got the actual microcontroller units that we're going to be using. We're going to be using one of these. The Raspberry Pi RP2350, which is a nice little microcontroller. And the radio module, which is in that bag there, which we'll open later on. So now comes the fun bit of getting all the components onto the board. But first we have to put solder paste on top, which I'll need to find my solder paste. No, we've got free solder there, but that's not solder paste. Oh yeah, of course, it's in the fridge. Yeah, you have to store solder paste in the fridge in order to for it to not expire, basically, and you can go all hard. So that's the solder paste. And then we've got our tweezers, which we'll use to space the components. We've got some flux here, which we probably won't need to use just yet, but could come in handy for later. And I might just try and see if I can get the... Oh no, it's all right, okay. I try not to burn myself or stab myself with the tweezers or something. Okay, so the first task is to use the stencil and apply solder paste, which is quite nerve-wracking because you have to line it up perfectly. And you also need something to apply. This is another stencil for another project, which I never actually ended up using. I'm just going to use that to apply the solder paste on top. So here it is, lovely solder paste. It's kind of hard to... The zoom on here is rubbish, but yeah, that's solder paste. That's what I used the other day. And we need to affix the stencil my work surface. For that I'll use some Kapton tape and some scissors, obviously, to cut it. So the stencils can be a bit annoying to line up. It won't come off across very well on camera, but maybe if I zoom in a little. Again, the YouTube mobile app is not very good when it comes to live streams, but there we go. Hopefully you can see what I'm doing. I'll do it over here. We're going to line up the stencil on top so that when we've got it perfect, we should basically see all metal rather than the green bits on the solder, on the PCB rather. What I'm actually going to do is I'm going to use these two PCBs. I'm going to line everything up on here and then use a bit of tape. This is because the stencil will arc at the edges, like it'll bend, which is not desirable if you want a flat surface to apply solder to. So I will apply that there. That one there. And then I might add a tiny bit of tape to the bit where we won't need to apply any solder paste, just to ensure that it properly secured. No, this thing won't go anywhere. Maybe a tiny bit more. I'm probably being a bit too excessive with this, but there we go. That won't move at all. And then we're just going to do the same thing with the stencil. That looks like it's aligned perfectly now. So, more tape just to ensure that the stencil doesn't move. That looks perfect. I actually use quite a lot of tape for the stencils because, yeah, I don't want it to move around and you want to ensure that the whole thing is perfectly flat. So you see how it kind of moves like that. It's not the most desirable thing. Sometimes I think it can be because the tape's in the wrong position, causing too much bending. I'll just remove this bit of tape, and if I place it right at the end, that will cause a bit there. I'll do the same with that one actually. I forgot that. I should probably have done this. Yeah, I know. Oh, first mistake. Throwing scissors on the floor. I can cut that off. Okay, my technique is probably really unsafe, but I won't worry about that. Also, I'm taking my time because it's not easy. I might reposition it a tiny bit. This is really fiddly. Right, that looks like it's properly in position. I'm particularly concerned about the pads where the RP2350 is going to go. I could use my magnifier. I'm not sure if you can see. There we go. We can see together. Use the magnifier to ensure that it's in place. Okay. I think that's the best we're going to get. And then I'll apply maybe some tape like this. Yeah, I think that'll do the trick. So far we've only really just put tape everywhere. It's not very productive of us, but the trouble is the stencil's so big for the board that it's a bit tricky, but you'll now apply some solder paste. So there's our syringe, and we are going to just, I think I'll start at the bottom. You don't want too much, otherwise you're going to risk a lot of the pads like sticking to each other, so we don't want that. And I'm going to use this other stencil, which I'm not actually going to use for anything, just to apply the pads. So far so good. We might need some up here. Yeah, the stencil moves around quite a lot. But I think that should be okay. What I mean is like up and down rather than side to side. If I've done this all wrong and we remove the stencil and it ends up all being the wrong place, then I'll just have to do it again. Just wipe the solder paste away and go back to the drawing board and just reapply it. I think generally that should be enough, maybe a tiny bit over here and over here as well. Doesn't matter if the pads are completely covered, because the solder paste will still reflow. Get one more swipe over. And hopefully, if we remove this now, I'm just going to move my Psion out of the way so that I don't accidentally do something to it and it breaks or something. Now I have to be careful about how we're going to remove this stencil, but remove bottom two, remove that, and hopefully, ta-da! I think I've applied quite a lot. It's hard to see on camera, but I think there's quite a lot there. So I'm just going to go in with a tweezer and kind of just separate it a bit. The magic thing about reflowing is that the solder paste will generally just fall into the right location. Pretty clever stuff. Just scrape it up where it's quite a lot. I think I remember having this problem last time. I did a project I put on too much and didn't look good. But I'll follow the advice of someone who's done this sort of thing before, and I'll remove a bit of solder paste from that massive pad in the middle. There you go. Oh no. That's okay. Maybe add a tiny bit. Oh, there we go. Because otherwise the RP2350 is just going to move about on the board. There's going to be too much solder paste underneath it to actually work. Just doing a few touch-ups where I can, some of the pins where it's a bit lacking. I think that might work. But we will find out. Time to now place components on the board. I'll just remove these bits. I'm definitely using all the tools inappropriately. There we go. I know it's standard practice to actually put other PCBs around the one you're working on, just to ensure that it stays in place when you're applying the solder. I'll move those out of the way. And I think we're done with the solder paste for now, so I'll just remove this little cap and put it back where it was. Okay, so now for the really tricky part, which is to and my phone zoom is not very good. It's now for the tricky bit, which is to place all the components on the board. So now I'm going to give you a wider picture of what we're going to be doing. And I'm going to go into the project, just over here. That's Discord. Doesn't look like I've opened KiCad or KiCad, so I will just open it. There we go. Oh, it's already open. Where? Have I just lost the window that maybe it's complaining about it being open? I'll just close that. Nope. Okay. Lowercase. There we go. Let's try again. There we go, there's our lovely PCB on my computer. So if I click this button here, it should generate an interactive bill of materials for, I'm looking at the wrong project. That was not what we were wanting. Oh. That's the one. No wonder it looked a bit different from what we're working on. I'll just choose a location. Yeah, that's fine. So what that will do is it will generate a HTML file. Hardware bomb, iBomb. No, I want you to open it in Google Chrome. Okay. Yeah, there we go. So on my laptop I just have a file which shows us where we need to place all the components, and I will change some of the options here so that there we go, that's what I want. So let's go through and place each component according to what my laptop tells me. Remove these stencils out of the way because we don't really need them anymore. Remove the tape as well, that's going to be in the way. This will either go really well or really badly. Let's find out. So, I have all the components here. We'll start with the capacitors first, which are somewhere in here. They're quite small things normally, so crystals. There's some capacitors. C17, no, that's not it. Let's hope we haven't failed at the first step and failed to have ordered the components. Ah, that's what we need. C2, C15, 13, 12. Yeah, that's the one. There's quite a lot of them. Time to zoom in so you can see better what we're doing. Again, this is on my phone, so my phone's a bit of a potato when it comes to recording things up close. But what can I say? So yeah, all the capacitors that we're going to be working on are on thin strips like this. For reference, here's the size of my finger. Sadly, I don't have a banana for scale, but yeah, each little black dot there is a capacitor, which we basically removed from this little, I don't know what they call it, a bit of tape from a reel, and then we place them on the board. I'm just going to do one final check just to see how well everything is aligned. Ooh, maybe I do need a bit of solder on the pins. I've just had a quick look again. There is a pad with insufficient solder, so I will quickly reassemble my syringe and tap it on there. It is a bit makeshift, but I mean, you can get the boards pre-assembled from your PCB supplier if you have enough money to. But again, it's a question of if you have enough money and not, like, you know, it is expensive to do it that way. And what's the fun? There's no fun in that compared to what we're doing tonight. I think that looks okay. Okay. Right, yeah, I'm satisfied with where the solder paste goes. And where has my live chat gone? There we go. Okay. So let's start with these capacitors. I'll probably place them going from top of the board to bottom. Just because that's, you know, a suitable order to do it. Being organised, that's what it is. And I'll remove the little film which holds the capacitors in place. It seems to me that the end of my tweezers are a bit bent. I wonder if I could squish it in place. Yeah, there we go. This shouldn't be this hard. Really am hacking away at the bit of plastic which normally comes up there. Oh. Okay, there we go. It's a bit hard to start with, but here my usual approach is to do that. And then we need to place one according to the computer. These are always really fiddly. We need to place one. I don't think my camera's very good at showing this, but there we go. There's the first one. If I use my magnifying glass, you'll see that there is a tiny little thing over here. That's where the capacitor went, but yeah, my camera's not very good. If I zoom out, maybe. Woo! SMD, yeah, I know. Yeah, should we just call it a day there? That's on. Right, project done. Okay, that's the first one. The good thing about the software on my laptop is that we can check off basically the to-do list of items to place, so that we don't accidentally get lost and start swallowing the wrong thing in the end, or placing it in the wrong location. Next one goes. Again, you need quite a steady hand in order to place all these components, but normally I need the magnifier for this, but it doesn't seem like I need to today, so maybe if I do that, there you go, you can see what I'm doing now. A bit better. So there's our second one. There's quite a few of these, the specific capacitor. I think this is the one which generally just decouples different, paths for powering the microcontroller unit. So, come on. There we go. Oh, yeah, haven't lost any yet. That's good. It's amazing with these little components. You'll soon find them scattered around your house, like in so many different locations, just as they go lost and then end up basically being like specks of dust. They're that small. I've been working on another project and I was very glad I bought spares for all the components because there's one little tiny weeny little chip which just went missing. It just disappeared. I keep removing the board and so you can't see where it goes. Once I place this one I'll show you what I've done. Okay, there we go. At the bottom of your screen there we've placed those two plus that one and that one there and that one over there. The capacitors are kind of blend in quite well with the colour of the solder paste, so they're not that interesting to look at on camera. But when we move on to some of the more interesting components, that's where the fun begins. So now, place that one down there. It's a game of Where's Wally trying to find it on camera, I'm sure. And that one goes there. I think that one might be upside down, but really it doesn't matter. Same thing. Okay, we've got 1, 2, 3, 4, 5 more of this one left. So just keep getting them and placing one. This one is right up close to where the microcontroller will be. There we go. I might adjust it a tiny bit. You really have to have a good steady hand for this, although normally I'm quite shaky with the hands when I'm trying to do something this small, but it seems once you got hold of a component and know where it's going to go, it is normally actually better than you think. Middle one. I'm working down here now. And the next one. Oh, almost lost that one. Come on. Get out. There we go. Okay, there we go, that's in place. And then 2 more, which are down to the bottom left. So yeah, these capacitors are mainly for power and just decoupling. Power supply voltage, just so that we don't get any noise from our power supply, even though this is like a battery powered device, but still it's good practice. People said on YouTube. Okay. So that's all those little tiny capacitors done. For that specific value of capacitor. You still got another 5, 6, 7 more to do. Okay, I thought we'd done with that then, but no. Okay, quick little inspection. We've put the capacitors down here and there, 2 down there, a few over here, up there, and our very first one which we placed there. So far so good. I'm just going to check if we have actually placed all of them, which it looks like we have. Sorry for any background music. I've got the window open, so when it comes to soldering, we don't smoke out the whole room with solder. But any cars which go past with loud music, that might be a bit annoying. Anyway, next is even more capacitors. Yay! Okay. Once again, same deal, just less of them. And here's the next one. Yeah, it's funny when you look on the camera. It's just tiny. It's like 1 pixel, maybe 2 pixels on video. That's how small these little clusters are. It is ridiculously minuscule, but that's what it is like. So let's place that. Where do these ones need to go? Okay. So this one actually joins one of the other clusters that we placed up here. Like that. So now I've got 2 clusters up there of different values. Next one goes in middle here. You couldn't see that one, but it's, where is it on camera? Down here. Yeah, again, capacitors are not really interesting. Luckily the resistors, I think, are coloured black, so at least you'll be able to see, you know, where they are. And time for the next one. The good thing, I mean, yeah, you're holding these things with tweezers, but at least there's no chance of crushing them because they are quite strong little things when it comes to, you know, using your tweezers and putting them together. You feel like something this small is going to break if you squish it, but no, luckily they are quite good. I mean, they are made out of ceramic and metal, so they're going to be quite strong. This one goes here. Kind of nudged another capacitor while I was at it, which isn't great. We've got 3 in a row up here now. I'm going to put another one to make it 4 in a row. So I should probably do this bit over here so you can watch me. Where did it go? Okay, luckily I got spares. Oh, look at this there. There we go. Yeah. And this one goes, I've forgotten now. There we go. There. You've got 4 in a row there. One for each viewer of this live stream right now. Have we done more? Let's have a look. Got 1 up there, 1 in the middle there, and 3 over here. Improve positioning. There we go. Yeah, again, sometimes it's not very interesting viewing because I'm trying to fix a positioning of a capacitor and you can't see where it is because it's not on the bloody screen. Alright, 2 more capacitors. Okay, we're getting through there. So let's pack these lovely little things back in the bag. So we're now going to do capacitor 18 and 19. Yeah, 19 capacitors. We've placed about, what, 17 of them so far, I think? So, getting there. These ones are 15 picofarads for those who are interested. And yeah, very small strip because I didn't order many of them. Probably ordered about 5 of them, or 6 of them. Which means I think I ordered enough so I can make 3 boards. Obviously, unless I lose a component, in which case I'm only be able to make 2. But yeah, all these ones are slightly different shade of beige, a bit lighter this time. Fascinating. Okay. Thought I'd missed a component then. So fiddly. Who would have thought? I wish they made bigger resistors that you could just easily slot into things like. Oh wait, they do. They exist. There we go. You might be able to see. Yeah, there we go. A bit lighter, so you can see where I put those 2. They're quite nice. The resistors should be, as I say, black in colour, so I have an easier time finding them on camera. Let me just seal up that bag and move on to resistors number 1, 2, 3, and 8. So yeah, look at these bags contain the information. Here we go. This one I've kind of had to write some of the numbers down because it was used for the other project. But yeah, it's really annoying with mouse. So if you're working on 2 projects, and I think it's just probably just my own fault. It doesn't add together your item codes. So I thought this was just for 1 project, this bag, but no, it's actually for 2 projects. But that's a whole other thing. Okay. See if we can find it. It's right here. Okay, there's not too many resistors, you'll be glad to know, until we move on to the more interesting components. I'll just wait up with this magnifying glass. There we go. Okay. So resistor 1, or well, there we go. Much easier to find now. Just touch up the capacitor which is sitting next to it. Okay. Next one. What time is it? We've already spent about an hour since I tried setting up my live stream. No resistor. Get off. There we go. This one goes here. There we go. Next one. Get it? Goes. Yeah. Go. There we go. When I first did SMD soldering, which this is my 2nd time by the way. The first time I tried it, I think the components just had a tendency to stick to my tweezers, so they didn't want to go onto the board, despite all the solder paste that's there. They just wanted to stand with tweezers, which was annoying. But this time it looks like I have a lot more luck with getting them on the board. Okay, so that's all the resistors. That's the first 4 done. Now just another 4 to do. Then we move on to some big fun components. Next is resistors 4, 5, and 6. If I can find it. I've got resistor 7, jumper 3, U2 and U1. Where's it gone? I had this problem last time. Where is that bag gone? I think I just must have accidentally put it back in the box with my other projects ones. This might be a problem if I can't find it. I'll throw it down here somewhere. I'm looking for 5, 6, okay. $100. Oh no. What could you do? It's a crystal. This is where I start to doubt myself and then think, where is it on the order? 204, 205. There's so many plastic bags that it can really get confusing. Alright, let's have a look through all these again. Y1, R7, J3, U2 and U1, U3, J1, U1. That's not got code U5. Huh, where have they gone? This might be a slight problem. They're 100k resistors. I seem to. Oh, they're on the ground, that's why. Last place I thought I'd look would be on the floor, but there we go. At least I have them. Mild panic. I've used these ones again for another project, so they're already open, but this needs to go in here. Let's get a better view. I really think I could probably do a better camera view than this, but again, I think we're quite limited by, like, we could have it overhead, but quite limited by the view. I should get one of those proper, like, microscope jobbies, which have, like, a digital display and you can hook it up with, like, HDMI. But, you know, I didn't think I'd spend that much money right now. Maybe next time. It goes, yeah, that way. Does it? I just realised I think I've placed 2 resistors in the wrong orientation. Namely, this resistor here, which, and this capacitor. The resistors maybe, hang on, no, I was right, don't worry. Okay, we're fine. I'm so easily confused by, I'll show you. This cluster of resistors over there, these 2 up here are going horizontally, whereas this one over here is going vertically, and I thought, maybe they should all be vertical rather than horizontal, so I thought, maybe I've done something wrong there, but no, that looks like it's supposed to be in the right location. So those are the 3 resistors we've just placed now. Okay, we're doing well. We've got 1 more resistor left before we move on to the big ones. Cool. Which is a single resistor, which is R7. Again, you still get really big mags, even if it's like that many. If they wanted to save the planet, I think that's what they should do, get smaller mags. It's understandable why they got different mags, but yes. Like you get like this for what will probably be like that big. It's like, wow, that is oversized. This one goes up here. Okay. Final resistor. Don't mess this one up. All right, that's on. I think you can see it. Yeah, that one there. All right, we'll go from really fiddly components to just fiddly components now. Go in there. Which are U1 and U2, which are our transceiver chips, and what they do is they we're back. Stream is, oh, there we go, the stream's back again. The wonders of modern technology. Okay. Where were we? Next component. So I don't know when the stream dropped out. But for those just joining us again, we've now replaced the two big transceiver chips. And I will just now apply some Kapton tape to the bag just to seal it up, so you don't lose any components. Otherwise, that would be unhelpful. All right. Okay. Next up is a smaller component this time, which is U3. Oh, they've put two electrostatic warnings. Maybe I should properly take care of destaticking myself properly. So it won't make much difference, but there we go. Is everything all right on stream? Yeah, nice. Looks like someone's come back, so that's good. Honestly, getting the stream to work on my phone is a nightmare. I mean, yeah, it's better with a camera, but you got to use what you got. This one's an easy one in terms of working out which orientation, because it's intentionally missing a leg. So oh, I dropped it. Turn it back over. It refuses to. There we go. Okay, it's intentionally missing a leg on that side, so we know pretty exactly where it needs to go. So I will. My magnifier is going to fall off the table at this rate. There we go. Now you can see a bit better. Okay. This one goes to the left of our transceivers, and I think this is used for. There you can see it. It goes there. It's used for power conversion. So the transceivers are converting the voltage for the logic levels to go into GPIO, whereas this chip is actually going to convert 5 volt power into 3.3 volts. So only this one can do it more powerfully than the transceivers can. So there we go. There it is. And check that one off my list. Still got another 9 more things to do, but that's okay, we're getting there. And because I've got so few of these little components now, you can work through them much quicker. And I usually just like to tape up the bag again, just to keep it in place. There we go. U4. J3, that's not what I want. Yeah, that's not it. Can I find it? J1, U5, another one that's on the floor maybe? What's it? Oh! There's a reason why I don't have it in those bags, it's because it's one of these. It's one of our... This is the tricky one. This is the RP2350, which is the brains of the operation, the actual thing that we can program. But it's got so many little pins on it that... And also, it's QFN, so it doesn't have legs so much as it's only just little pads on the bottom of itself that we just have to carefully align on our board. So yeah, very tricky on this one. But I want you to all be able to see it. Oh, again, I might scrub a bit more solder paste off, just like distribute it, just so that you don't have any issues with that. And you don't want too few, otherwise any heat won't be able to dissipate from the board well enough. So that looks like it's on. Whether my solder paste application job works is another story. Probably a bit too much solder paste down here. Okay, so I'm just going to blur off. But just want to line it perfectly. There we go. That looks like it's on. Again, I'll just extra push it down a tiny bit. Okay, moving on to an easier one this time. Which is U5, which is this massive bag. I have to cut it open. But it's for such a tiny component. This is going to be the flash chip. And it comes in all this anti-static protection, the old do not eat silica gel. I'll try a bit of that later. Should be quite nice to eat. And in here, really proper knife that there you go. Oh, it's one of these which tripped me up last time. It's got a little thing in it. Come on. There we go. Little box which then that's how big it is. It's ridiculous, but I can see why they do it. There we go. That for that. But you can't complain. At least it's well protected. I'm just going to refer to my PCB design on my computer just to see, again, its orientation, and yeah, it's pretty clear. I think you can see it on the PCB this time. There's a little dot over here somewhere. Can't make it out on camera. So that means our PCB has to go do a 180. And we'll place that. Oh man, it's got a tiny bit. So the face off first. We don't want it to end up with the same fate as what would happen to the RP2040 or the RP2350. Apparently there's going to be a new Raspberry Pi chip which will eliminate the need for any sort of flash, external flash at all. It'll be built in. I think it's the RP2354. So that'd be nice. Okay, that is there now. I'll do another light tapping just to secure it in place before I turn this thing back into its massive anti-static bag. Growing this little garbage. Good measure. And take that shut. Like that. Okay, that's that one done. Okay, yeah. Next one is the Raspberry Pi Radio Module 2, which is in this little pouch, and I've only got, I should have two of them. Do I have two of them? Okay, I must have only bought one. Oh, I think they probably came in their individual bags, because Pomeranian are not, they're not as capable of like putting stuff in the same bag as like mouse. I mean, they're just a general maker company, so I think they just put the one component per bag like already pre-sorted, so that explains it. So I might have another bag with another radio module in somewhere. So you at least got a spare. Okay, and this is the chip that will hopefully give us internet over Wi-Fi. I'm not sure I should place this one with my fingers because it's quite difficult to place with tweezers. SMD soldering by fingers. I'm not sure if this is a good idea, but maybe at least to place it. That'll do. It's a big thing. Definitely the biggest one on the board. Just want to make sure it's aligned nicely. I'll push it down. There we go. And then for the remainders, oh, we do have, okay, I think we only have two more things to SMD, place onto the pad. The rest of the components, which include like the actual connector at the bottom, is just going to be through-hole soldered, so a bit easier in terms of scale. Y1, yep. This is a crystal Weirdly, sometimes the component names start with a Y, sometimes they start with X or Xtal. For whatever reason, KiCad or KiCad decided we'll just make it start with a Y this time, so there we go. And placement wise, I don't think it really matters too much with crystals, but yeah, it looks like it can rotate both ways, but I'll place it however I see fit. Yeah, the pins are going to be the same, so I will place it here. Nice. And then, before we forget, I'm just going to go through my... Weirdly, that the software lists my test points as components to place when they are just test pads, so it doesn't matter. You know, that doesn't matter. Final SMD component before we turn on the hot plate. This is exciting. I'm going to place these crystals back in their bag before I lose them or get them confused. Easily done, given how small they are. And here we are. And they do have a bit of capsule tape on them, interestingly, because they are mounted from the top. Bit of film that they're using, which is strange, but not out of the ordinary. I've seen it before. And on it goes. It's so tall that it's kind of hard to work out the alignment that easily. When you're looking from the side, you have to look at it head on almost. There we go. So that's what could be considered the boring part done, although it is quite, I don't know, rewarding placing each bit and it looking like it's the final PCB, even though it's not even been put on the hot plate yet. But so just put those components back. And time to boot up the hot plate, which doesn't take too long to get up to heat, but there it is. This is a USB-C powered hot plate, which uses USB-C power delivery. And it's very cheap. It's only about 20 to 30 quid, I think. So, not a whole lot. Luckily, it does not set fire to your whole house. Yet. Turn it up to 240. Okay, we haven't turned it on yet, but yeah, it's quite cheap, quite effective. It's quite small, obviously. When I first opened the package and saw it, I thought, wow, that's tiny. But it does the job. And I'll move that out of the way. I'll just use it as a light for now so you can see what we're doing. And we'll move that. And I'm just going to do a quick spot check before I heat the board up. Just to see if everything is in place. It looks like some components have kind of shifted a tiny bit. Weirdly. These tiny little resistors and things, they kind of might have moved around while I was moving the board, but oh yeah, there's especially over here. Some of them are quite hard to reach now because all the big components are now on. Show that there is one in the right position. There's always a risk of the capacitors tombstoning, which means that they kind of pop up out of their place and look like a tiny little tombstone on your PCB. If you imagine your PCB being like a graveyard. Which, let's face it, if it doesn't work, then it probably will be. I know that my hot plate is quite dirty. Ignore that. I had to desolder something and I thought, oh, maybe I'll use the hot plate as like a surface to help with desoldering. And it did work, but probably not the most effective use of it. You won't be able to see this on camera, but there are a few resistors, etc., or capacitors, which are kind of slightly out of place. Oh no, I've dislodged a chip. That's okay. Alright, concentration, there we go. Doing final look. Everything's more or less in place. Apart from this radio module, which has now been knocked around a tiny bit. Which is quite a mean feat, given how big it is. I'll squish that back into place. How does that look visually? My eye. I think that looks okay. So let's heat it up. Yeah, let's do this. And I'll zoom in a tiny bit. There we go. 26 degrees right now, but time to fire this thing up. There we go. There are buttons at the back, which on these sides at the back, left and right, which you use to control the user interface on the front. But I don't think it's the safest place to put them. you very much risk yourself burning, but being burnt, touching them if you're trying to fill about the back. But whatever. Right, let's see what happens. I'll use the magnifying glass as like a preview for you lot. 135 degrees. We want to reach about I said it's 240. That way, the board itself gets up to about 210 degrees. Like we do lose a few degrees of heat being transferred between the really hot plate and the board. Understandably so. It's not completely. There's a bit of smoke coming in now. Oh, everything is now starting to settle in. Okay, there's a few solder bridges on the Raspberry Pi, but that's okay. I might edit, so to speak, the radio module. This is the perfect time to fill them out and reposition certain bits. Now or never. Oop, burnt myself then. It's okay. It may be about 200 degrees, 193 right now, but it doesn't hurt that much. Not if you touch it briefly. Okay. Might require a few touch-ups here and there. Oh, no. I'm about to say the capacitors and stuff look fine, but there's one capacitor which has moved ever so slightly. I will be going through all this with a soldering iron anyway, just to, well, not only just, fixing up a few bits, but also attaching the connector as well. So everything's a bit shinier now in terms of the pins. That RP2350 doesn't look in the best state in terms of the pins. There's quite a few over on this side which look like they are properly like not bridging and stuff, but that's okay. 220 degrees now. I still see bits of solder paste, but maybe if I move the board gently over here. Radio module, some of the pins are down, but lacking in some of the areas. So yeah, give it a few more moments just to settle. Move a few components where I can just to touch them up a bit. Obviously I can't touch the PCB now because it's hot. Otherwise it looks like everything is in place. It's a very good sign. I think I can just nudge the RP2350 there. There we go. I think if I go through a soldering iron now, I can touch a few minor bits up where like there's a tiny bit of bridging, for example. So I'll just shut down the hot plate and I will now get my soldering iron out. It's not a very good soldering iron, it's just one of those ones which directly plug into the wall, so not one of those fancy ones with like a screen on it like the Pine Sill, but I think I might get one of those at some point. Just to have more accurate control over temperature, and also reach higher temperatures as well. But I'm going to use this fine tip on the end of my soldering iron today, purely because we need to reach into certain little nooks and crannies that may be otherwise hard to reach using the standard tip, the flat one almost. And I will need to get that. Okay. Make sure I'm soldering on it. There we go. Just change the zoom out a bit. I've got my soldering iron on the right there, which is just warming up right now. Hopefully it doesn't melt my cable to the hot plate, but we'll be turning the hot plate off anyway soon, so let's make a few touch-ups. I might actually try and boot the Raspberry Pi chip on there before I solder the pins, just to see if the Raspberry Pi is working, of course. Otherwise, I am quite happy with most of what's going on here. But yeah, it's just, yeah, you can see on camera like some of the pads are bridged, but that's just to be expected. I think I expected that from the beginning, so I knew that I have to go in with the soldering iron and just go with it. But this is now at 80 degrees, so everything should certainly be immovable now. So I'll just remove this from the soldering pad so it has time to cool. The plate is a bit dirty. It's a bit dirty on the back, but nothing that a bit of like isopropyl alcohol won't fix, but that's okay. Just a cosmetic thing, not a functionality thing. Zoom out. There we go. Yeah, time to kitchen roll. And I might need some solder as well, which I do have this one, but I don't think my soldering iron can quite reach the right temperature in order to solder this. It takes forever to melt this one. So I might have to switch back to leaded solder, which is, probably not as nice, but at least it has a lower melting point, so it's a bit easier to use. I think the soldering iron should be hot enough now. So I might just tin the tip, just ever so slightly. And yeah, you can see that, there's a tiny bit. A tiny bit molten lead-free solder on there, but yeah. I'll wipe a bit off because it's probably a bit too much. Okay, cool. So I might also add a bit of flux to this as well. So to do this, I have a very handy brush, which I bought from a very fancy supplier called WH Smith, which I use to just apply my cheap Chinese flux to the board. And that should hopefully just make the contacts a bit nicer to work with, especially around the Raspberry Pi chip. I'm going to do all sides. I think there's enough flux, like, it's kind of hard to see it on camera and in real life as well, so bit of a trial and error sort of game this, but let's use soldering iron. Yeah, now you can see it. And I'm just going to run my soldering iron slowly over the legs, and it looks like that has corrected our bridging issue now. You can see, you've already seen on camera now that there aren't really any bridges other than on the left here, so I'll just keep doing it until it looks okay, really. I think I've made one big bridge. Let me wipe the tip of my iron just to reduce the amount of solder. Yeah, this is quite odd, but maybe if I try and put more solder back on. So you can reach into there. I think I might need to use the microscope now just to have a closer look. Yeah. I mean, the problem is that I think, yeah, this tip is actually not as good as it is made out to be. So I will try and switch the tip without causing too many issues. It's still hot. I will very stupidly use a pair of pliers to try and remove it, and I'll put on the small, this one here, which might be a bit better. Let's try that. Yeah. Right, that one's off. Okay. Time to, yeah, I got that other other one on. It doesn't look too different on camera, but I'll switch this back on. For those who have just joined, we're just trying to touch up the seat of the RP2350, which is something which is expected. We'd have to do it. It's never perfect, but yeah, there's just a few issues with that which resolve. So I think this tip is even worse. Ugh. Has it reached temperature yet? No. It's very hard with a soldering iron which doesn't give you temperature feedback as to how hot it is. There we go. Now we're up to temperature. Okay. Where are we looking? Over here, yeah, you can see the massive bridge. And I need to somehow use this soldering iron to correct that. Hopefully without burning myself. I think that might be doing something. I'm just going to use the... Yeah, no, it's... Yeah, I've actually used leaded solder. Era appropriate, I guess. I won't sell this one though, maybe, as I... You can't really sell things with leaded solder, at least if you're a massive company, you can't get away with that, but... Tinder tip again. Lead. Oh, there we go. Maybe we're just not still getting up to temperature. I don't know. Maybe there's a tiny bit of lead. Or, I've done this in the past, with the last project, use a bit of solder paste while we are using the soldering iron just to easily apply solder where we want it to be rather than having to faff about. I just want a tiny bit more there just so that we can more easily reflow some of the pads. This will start to, there we go, melt in, and I think it's got flux on it as well, which is quite handy. I have no idea if that's bridged or not, but to be quite honest, I think some of these pins are just going to go unused anyway, so it's alright. Let's try doing one other side. Wipe off a bit of that. Okay, it's starting to look a bit better. This one we have to be extra careful because there's a capacitor next door. I don't think it can reach that bit, which is super annoying. Yeah. I'm going to need to remove the capacitor in order to reach. Yeah, the situation update, there's a capacitor there, and that is where the bridge is. So trying to reach the capacitor, or reach the bridged pads when the capacitor is in the way is not exactly ideal. So I'm going to remove the capacitor, like so. There we go. That can go on later. And re-melt this side. There we go. Still almost all the bridges, but looking a lot better. Okay. Yeah. That's looking a bit better. It's kind of impossible to see what's happening underneath though. Unless I put this back on the hot plate, which I could do. But I think I'll boot it up first. Let's see if I can program this thing from my computer. I might just get it to try and, I don't know, write a value to one of its GPIO pins maybe. I'm just going to compare visually just to see how that looks. Looks like there's certainly less solder bridges on this side. It is really a game of trial and error. No. This is the sort of thing which takes hours to try and get right. Maybe. Problem there's so much flux in the way you can't really tell that easily how well it's going. Can't really tell from the light, from the magnifier, whether like it's actual solder bridge or if it's just a bit of flux which is reflecting. So I might change the colour. Yeah, I think warm colour will work a bit better. That's too much solder on this. Okay, I managed to remove a ball of solder there, which might change the job. I think that looks much better. Certainly. There's a point where I will have to stop. Just a question of when. Okay, just scraping away a bit of solder there. More solder bridges. Probably not interesting viewing, but there we go. I think I'm getting there. Wipe the tip a bit more just to ensure that I'm not adding solder rather than removing it. You can't really stop until... I think I might use a bit of kitchen roll just to evaluate whether there really is flux that's making it all. There's a little pasta that we need to go around and plate on. Whether it really is all flux, or if it's... That's definitely solder. Annoyingly. You can feel it with the tweezers when there's a solder bridge, because it should feel all jaggedy, but to use the technical term, but yeah, it's not. I wish Raspberry Pi made a bigger version of these chips. Like, I know you can get modules, much like the Wi-Fi module I'm using, but that you could put on top, which I would prefer, but some of them should be a bit too big. It's like Goldilocks. I think, yeah, what I'm going to do, plan B, I'm going to heat it up using my hot plate. I'm going to lift the RP2350 off the PCB and just have a look at the pads underneath, and then do a bit of alterations if necessary, and then place the RP2350 on. But I'm not sure how well that will work. I think I've done it before last time with another PCB project, and it worked. Because it was me just checking what's happening underneath, but the pins are not as small as what's on here. Like, even on camera, it's so hard to make out how big how small those pins are compared to everything else. Even the capacitor pads are bigger than the space between the pins on this board. It's kinda mad how you're expected, like, as a hobbyist, to put these on at this size, but I guess you have to be skilled at it. Okay, things should be movable shortly. So I'm going to use my tweezers just to remove a chip. Oh, that was definitely movable. Big reveal for what's underneath. I didn't let it go up to temperature enough. Maybe we should stop being impatient. 203, 204. Because if you try and lift something, well, it looks like it's melted, like it's at the molten temperature. When you try and lift the component, it will not come off because it's not quite this like molten enough in order for the component to come off. So I think that's good. There's a lot of surface tension as well, so. I always use my soldering iron as like a holder, so I can keep touching. There we go. So what does it look like under there? Looking under the actual chip, it seems to be okay. And looking at the board, it could be a bit better, I suppose. I can always use my tweezers as like a impromptu soldering iron to. I wish the camera would focus a bit more. If I adjust it, I could use the tweezers as an impromptu soldering iron just to make a few minor modifications. I can see there's two traces with two pads which have excess solder on it. There we go. I've moved that bit. There's a tiny solder bridge on the right. I'm gonna have to describe this to you because you can't see it on camera. There's a tiny solder bridge on the right there, over here, which has for the most part gone now, but though it will not look like it on camera. But just gonna use some tiny traces of solder. I think this is the way. I think for these, dare I say it, I think for these QFN chips, I reckon when you're using a hot plate, you have to apply the solder paste as you normally would, and then heat up the PCB without the chip on it, and then place the chip afterwards. That way the solder has had time to settle into the right pads before the chip goes on. Because, when the chip goes on, you don't really have much leeway to fill about with the solder underneath. So I keep on thinking to myself, like, that could be the strategy, but I haven't tried it yet. There's still a tiny bit of solder on one of the pads, which I will attempt to try and do a close-up. Oh no, I've made a bridge. I'll attempt to do a close-up of the camera just so you can see exactly what it is I'm looking at in a moment. Okay, let me attempt to show you. Yeah, my zoom does not do it justice. Maybe if I bring the camera. No, I'm going to detach the camera from my tripod. Ooh, there's one hot phone. Yeah, you can see the pads. They look a bit better in real life than what it looks like on camera. I think it's just the angle. Let's look at it from above. Yeah, so here's the pads. Right now I've removed all the solder, any excess solder where the pads are bridging, but and now they're shiny. But yeah, I think it's a very tricky thing. Let's reposition that and then replace the chip and make sure it's the right orientation. Okay, looking at the other side of the chip, it does not look perfectly healthy. Oh no, it looks okay. Difficult. I had a similar fate to the other PCB that I've worked on before, so and that one worked. So yeah, I guess I am not bad at it. Just need more practice. Now I have to drop it on. I think that's in place. Quick inspection. Yeah, shifting a tiny bit. Use my soldering iron as a holder. Okay. One last visual inspection before I move on. The chip is not straight at all. It's getting late as well, I'd say. This thing will take forever. The underside of the chip looks okay. So all the pads look like they've got tiny bridges between them. Maybe if I paint on more flux. That usually gets the things a bit more tidied up. Yeah, there we go. Getting a tiny little solder ball which has come off, which I think is a good sign. Because that solder has nowhere to go. So okay, cool. Looking at the other side of the RP2350, I'll do it with my fingers. There are definitely areas where it needs to. I'm going to just touch it over with a soldering iron just to straighten out some of those pads. Well, not straighten them out, but remove bridges. Okay, that looks okay. I'm glad I got the window open. Otherwise it'd be quite warm in here by now. All this soldering iron and hot plate business. Okay, that's on. it certainly passes the vibe check, that is that everything looks like there's no bridges. There may be very tiny bridges underneath though, that's my only concern. I think that looks like it's almost more or less on. Okay, let's touch up some of the... let's move on. Let's touch up some of the other bits. I think actually, before we let this cool down, I'm going to move that solder ball movement tweezers in there. Yeah, reposition it onto the other pad. You think that with reflow soldering using a hot plate is going to be super easy because everything falls into place, but well, most things fall into place. Other bits do not. Okay, that looks alright. And I also remember that we've got a capacitor that we need to place back on somewhere. Yeah, I'll see where it is. What time is it? It's nearly 11 o'clock in the UK. Not very good viewing. There you go. Transceivers look soldered open. Okay. Rest of the components. Yeah. Reposition. How's it looking underneath our flash chip, I wonder? They're only like eight pins, so it should be okay. Yeah. There's definitely not enough solder on there, so I'll just use that little ball. Solder. Or maybe apply a tiny bit solder paste. There's like two pins which look like they... There we go. We don't have enough solder on them, so place that back, and that looks like that's okay now. So I'm not concerned about that now. Just a radio module now. And I've lost that capacitor. That's not a capacitor. Right, you always lose one tiny component, so I'm going to have to find out which it was. Okay. C2, C5, blah, blah. There's resistors. It was our very first one that we needed to use. So many components that it's almost impossible to track them all. I could put them in order, but There's not many of them, so it's alright. It's a good job I have a lot of spare capacitors. Okay, let's replace that capacitor that we removed earlier. And to be quite honest, if the capacitor isn't... Actually, I don't think it does much if we leave it out, but for completeness sake. There we go. But it's all the paste that's true, it seems. Let's look at all the other capacitors. They look okay. Maybe this bottom one down here. Need a bit. Ooh, I've displaced it. There we go. Okay. And then the radio module doesn't look like it's got nearly enough solder on each pin, so I'll just either go through with the soldering iron, or I could just go and apply it just like that. And that looks like it's doing the trick. Last thing we want is the radio module to fall off due to insufficient solder. Especially because it looks like it's kinda not exactly flush with the board for some reason. Oop. Got a bit on the shield, but that's okay. The shield will just have to have a bit of solder on it. It doesn't matter if you get a bit of solder on the shield, because the shield's made out of metal anyway. And yeah, it happened to me in the last project, and it's still, like, the radio stuff is still fine, so unsurprisingly really, so okay. Maybe a bit less solder on that pin. Oh no, I bridged them. Let's wipe it away with a tweezer. There we go. Position wise, I think I'm happy to turn that off now. And try and power it up. Although I realise I will need some way of connecting it to some sort of power. So I might use a agent to power it using probably... I could power it with 5 volts, I guess, because that's what we'll be outputting. Okay. While that cools down, I'm going to try and search for a Raspberry Pi thingy. Yeah, let's just use this one. Unplug all this. Let's just use this existing high pico and just power it off USB, and then probably I could solder a jumper cable to the right pins. I just need to work out which pins they are. So down here, on the connector, before I attach the actual connector on the end, I'll just solder some pins just to power up the thing, and then I can plug in the debugger cable. And yeah, let me have a look at the board. Okay. Zoom out so you can see my laptop. And zoom back just a tiny bit back in. Okay. On my laptop over there, I can't really screen share it right now, but we have SVCC on the top left there, that pin, which should be 5 volts. That's what the Psion gives to the data pack in order to power it up, and you've got ground on the pin next to it. So hopefully we can solder that to our circuit board. Move our little thing out of the way. That's at 90 degrees, so we don't risk moving things around. Board does come a bit stuck to the, it's okay. Alright. I want to do our test points in the back, but I'm not sure how I could connect. Yeah. Alright. Let's use some lead solder and tin the tip. Just get that soldered on there, maybe. I don't think that's going to work. I'll solder it through hole. Actually, white should be ground, I think. And then the coloured one should be 5 volts. World's jankiest 3-hole connector. Now, whether this will work first time, I don't know. Okay, that's on by some definition of on. I might need to use my solder sucker there. I accidentally put a bit of solder through one of the holes, which will make putting our connector on really difficult later on. I could use my tweezers actually. The tweezers are the answer to everything. If I just solder my tweezers to there and then pull the tweezers out. There you go, there's still a hole there. Nice. I think I'm committing a lot of hardware assembly crimes right now. But it's a personal project, so especially with a slight disregard for health and safety in some places. I don't think these pins are particularly well designed for solder to go on them. But that's okay. Too much solder on the end of my tip. Now I've created a bridge between 5 volts and ground, but it's no good. Alright, solder sucker time. There we go. Magic. Okay. It's a bit warm. we got pins on there. We've got jumper cables on there, but on the other side we have a bit of solder there, but that'll be fine. Now, which one is 5 volts? Sadly, they don't really seem to label high pico 2W pin out. They don't really label which pins are which. We want V-bus and ground on there. Okay, V-bus, V6 and ground, okay. Let's stick V-bus into there and then ground into fiddly. Come on, this is not the most fiddliest thing we've done today. And ground into there. What could go wrong? Let's find out. I need a micro USB cable. I've got one here. The main objective, I think, if I should probably get my multimeter just to take some measurements. The main objective here is just to see if the power's up. We'll worry about programming it in a moment, but just to see what our power rails are. See if we get 3.3 volts. I've got my yellow multimeter. Again, very cheap multimeter, but it measures stuff, so it'll probably be alright. Here goes nothing. Get out of the way. Oh, there's a lot of heat on the RP2350. So there's definitely a solder bridge there. I've got 10 of them. Maybe I should just use a different one just as a clean bit of solder. Multimeter on the floor. Very professional that. Let's just desolder these cables. I think this is going to take a while to... There we go, that's ground out. Yep. It's always a good idea to have your finger just on your key components, your microcontroller, just to see if there's any heat coming off of it, because that's a good sign that there's a short circuit. And that's what happened here. Just trying to remove the jumper cable now. As you can see, I'm glad that I didn't solder the connector yet, because trying to desolder 3-hole components is a nightmare. I'm just using a bit of force, just to, not too much force, but a bit of tension just to remove the cable, the jumper wire from the, there we go. Right, back to the hot plate then. Heat up. There's a tiny bit there, solderable there, so I'll just melt it off. I think I definitely used too much solder paste at the start. Will I ever learn that lesson? I don't know. but then you don't get enough in some other areas, so it's really hit or miss, even when you align your stencil perfectly. Yep. Yeah, so let's get another. We've got plenty of these, we've got 10 of them, which is like a lot. Oh, RP2350 went flying then. Let's just replace this one on the board with another one, just because I feel like there's some of the solder pads under there, there's too much solder on it, and they're touching each other, which is not great. And you don't want that, so... I also realise there's a tiny solder bridge between some of the pins of the transceiver, I think. I need my magnifier. Yeah, there is. I think this transceiver needs removing from the board, just briefly. Yeah. Okay. Yeah, transceiver won't be the root cause of the short circuit issue, I don't think. Okay, that was looking pretty shoddy. I need some flux on there. Maybe. Gut instinct. This might go on for a while. Yeah. Bit of flux cleans those up just perfectly. This is definitely not the way they do it professionally. But I'm still a beginner. Just flux. Transceivers look okay. It could also be capacitors which are causing the problem. But my main suspicion is around the RP2350 because there are a lot of close-up pins. So I'm going to replace it. Usual soldering iron trick. Okay, so replace that with this one. Need a magnifying glass. The way I'm holding the soldering iron is definitely not recommended, by the way. Okay, looks like it's sat on there quite well now. If it still continues to heat up excessively, then I will remove it and just do a test without it. If I can remove it, solder from there, not easily. Okay, that's okay. Oh dear. Alright. While that cools down, I think I will just check what power we're receiving from a high pico. Gives us something to do. Yeah, 5 volts. That's what we'll expect. We will let that cool down. I wonder if we use a bit of tissue paper just to kitchen roll just to wipe off any of that flux. Using the brush just to not really. Okay, it's definitely below reflow temperature now. Visually speaking, I don't see any like bridges over the capacitors. I think that could be the main problem. I'll let it cool down a few moments because it's still quite a hot board after taking it off the hot plate. I think what I'll do is I'll just touch the cables against the PCB this time. That we would have to go to trouble of soldering them and then check if they work. Hot board. I just let it cool down in the air. It's now fine to touch, but yeah, visually. Let's get a closer look. Yeah, no solder bridges on the RP2350 pins now, but nothing immediately springs to mind. The back is a bit dirty, but it's the back, like, doesn't matter too much. I might use a bit like alcohol, isopropyl alcohol, or that sort of thing, just to clean up any like burnt flux. It's still cooling down, it's still quite warm. It's amazing how hot that hot plate gets when you turn it on. I'm just kind of waving it about just in the air just to cool it down. Okay, it feels cool enough. Here goes nothing, so I need to remember that the ground pin is on the right, otherwise we'll get the wrong party. It'd help if I plug the USB cable into my computer. And this is what we do. yeah, it's still bloody boiling. It very quickly heats up, which could suggest a capacitor problem. Maybe. Or something else. I could attach alligator clips to the test points on the back just to see what voltage we're getting out of the 3.3 volts. I think that would be quite handy. What I'm going to have to do that is get some more alligator clips. Probably going to be never ending. And then these two will be on the same rail. I don't actually have any alligator leads which have the clips on both ends, so I'll just use my rubber. That's okay though. So this one will connect to 3v3. And this one to ground. That's okay. No, it's the same deal. The inner one is ground. Okay, here goes nothing. You're reading exactly 0 volts on the test points. But I'm not sure if that's just because the quality of these clips, I don't know. Oh, it's because the cable fell out. Right. Okay, so it's 3 volts over that. So that's working. Is it a design fault or what? I'm going to have to look at my computer just to see what's going on. There's a schematic over there which I'm referring to. Frequency volt regulation transceivers. Data pack connector. About RP2040 gets very hot as usual. Maybe it's a good idea to work out how much electricity, how much current is flowing through the board, how much it's consuming. Let's do that. So in order to do that with the breadboard, you have to wire it in series. So I'll just do that now. The things you have to do. That's going to be that, and then ground is going to be through there. Okay. Yeah, you're using overloaded. How much is that? Not even reading it anymore. Have I killed it? Does it still at least get hot when I touch it? Yes. It's, yeah, there's a short circuit somewhere. I'm not sure where. And yeah, when I touch my finger against the microcontroller, it gets really hot. I just need to review why. I think I might have to back up soon so I can go to sleep and work on it the next day. But maybe it's that capacitor. Oh, that's a good idea. Maybe instead of doing that, I should check use the multimeter's continuity mode just to test each capacitor. See if it really does not have any bridges or anything. Okay. Let's have a look at what items on the board are capacitors. I'm pretty sure all these down here are capacitors, they look like it. So I'm going to adjust this so that you can see. Nope. Nope. Oh, there's something. That's okay. I think it's most likely going to be something. If the board is the CPU's hot, then it'd be a short circuit underneath it, right? That resistor should read something. Yeah, that's a resistor. Okay. Now, I do know that what some of the pads are, so maybe. Oh, what if I check, use the test pads just to see if there is a bridge somewhere by touching ground and 3 volt, 3.3 volt. It reads 400 on the multimeter, which is getting quite close to being a bridge. 3 top there. Ooh. There are 2 pins where 3.3 volts and ground will be in like right next to each other, but I don't see any issue with that. I think I'm going to have to go to sleep now and think about it later on. So on that disappointing end, yeah, I will see you all later.